this video we're going to take a look at inverse functions for quadratic functions, and it starts the exact same way as we would any other inverse functions question, and that is by replacing f of x with the letter y. So we say y is equal to the function, which is x squared plus 4x minus 6, and then for this one what we need to do here is complete the square. Now for that, if we are to make this quadratic into a completed square, then what I need to do is have a squared plus twice the product. So that's twice the product plus b squared. And then that all could be simplified down to a plus b squared. So I need to work out what the b squared part is going to be, because currently that minus 6 doesn't quite fit into that. So what I do for that, and you'll see lots of other solutions or approaches to completing the square online. For my way, what I like to do is line it up like this and say, okay, x squared is a squared, therefore the a that I'm aiming for in this one is actually x. Then my twice the product, my 2ab, is equal to 4x. Now I actually already know that a is x, so I'm going to replace that. So I have 2xb is equal to 4x. And then I'm going to divide both sides by x, and I'm left with 2b is equal to 4, and b is equal to 2. Now that's told me what b is, but what I need to fill in here is not b, but b squared. So what I need to do is square that value. And what I'm going to get is that b squared is equal to 4. And I'm going to put that in here then. That's squared b. I'm going to add that in. Now I can't just throw in a 4, because that's changing the value of the function and all of the outputs of that function. So what I need to do then is to make sure I haven't changed the value of the function is also take away 4. Okay, so what I'm going to do is copy and paste it down here so we can do the rest of the work. But that's basically the first step to completing the square, is figuring out what is that b squared that I'm missing. Add it in then for yourself, but make sure that you haven't changed the value of the function by also taking it away. What I'll do then is that is the completed square part that I've worked hard to put together, and I'm then going to say y is equal to x plus 2. I'm factorizing the quadratic here. I could do x plus 2 by x plus 2. That's it factorized. And then I'm going to have minus 6 minus 4, which is minus 10. And then this, if I've two things that are multiplied by each other and they're actually the same thing, a shorter way of saying that, if it's multiplied by itself, is x plus 2 squared. So I have x plus 2 squared minus 10 here now. At this stage, I have not inverted the function. I haven't got the inverse yet. Now I start that process. So all I've done up to this stage is I've completed the square, and I've done that using the concept of a complete square to do that. Now, at this stage, we're going to start our inverse. So you're going to basically do the reverse of the BIM-DAS steps. So ordinarily we would do the brackets, the exponents, the multiply, divide, add, subtract, but actually when you're trying to invert something or reverse things, you work from the end back up to the top. So I'm going to start with the subtract and the addition. So if I've got minus 10, what I'm going to do to reverse that is add 10 to both sides. So plus 10 to both sides leaves me with this. And then I ask myself, okay, that's square. What's the opposite of square root? How do I undo a square? And that is square root. So we're going to square root both sides because I want to undo the square here. Now, when I do that, they're undoing each other. And I've got x plus 2 is equal to the square root of y plus 10. And then what I'm going to do is subtract 2 from both sides, because remember the goal is still the same, to get x on its own. I still want to get x on its own, and if I do that, then what I'm going to get is y plus 10 square rooted minus 2 is equal to x. And then at this stage, you replace your y and your x again. So just swap the symbols. I'm not manipulating it anymore. I'm literally just swapping the symbols around. So I'm going to have x plus 10 square rooted minus 2. And then, of course, you can write it as your inverse function then. The inverse of f of x is equal to the square root of x plus 10 minus 2. And that's it. Now, I'm going to do another example here. It's the same process each time. First thing, start by replacing f of x with y. Y is equal to x squared minus 8x minus 3. And then what I'm going to say here then is I'm going to have to complete the square because that's the process of a quadratic. So to complete the square, I need to go back to that idea of having a squared plus 2ab plus b squared. So that has to be, if it is a completed or perfect square, I'm going to have this scenario. Now because it's a minus here, I can actually say, right, minus 2ab, and if I was to break that down, I would be getting this completed square. And again, what I do, and it's only one way of doing this, you can do other ways of completing the square. I like to just match them up and say, okay, my a squared is x squared, therefore a is equal to x. My 2ab, in this case minus 2ab, is equal to minus 8x. And then if I am to divide both sides by x here, how do I know it's x? Well, remember, a was x. So I'm going to put my x there, and then I can divide both sides by x. And then I'm going to be left with minus 2b is equal to minus 8. Then I'm going to divide both sides by minus 2, and I'm going to get b is equal to 4. Now remember, we didn't want to sub in b, we wanted to sub in b squared. So what I can do is say b squared then is equal to 16. And then I can put that into the function. Now we must remember that I can't just add in 16. I can't just say plus 16, there I go, my completed square, happy days. I actually have to remember that that's a function that's going to generate outputs, and I want to make sure that even though I've made this adjustment to the function, to restructure it in a new format, I need to make sure that it has the same outputs. And so I'm going to take away 16 at the end here as well. So all I've done there is added in the b squared to suit my needs to be able to restructure it. But if I take away 16, I've not actually changed the value of the function at all. Again here, what I'm going to do is bring down the function so we can do our factorising and our completed square and finish off the question. So I'm going to have y is equal to, if I was to factorise that right now here, I would have x minus 4, x minus 4. So I'm just factorising the quadratic and that's what I get. Minus 3 minus 16 is minus 19. And then I'm going to have y is equal to, remember, if we have this multiplied by itself, a faster and neater way of writing that is x minus 4 squared. And then I'm going to have minus 19. And then what we do is we still want to invert this function. We want to get the inverse. So what I'm going to need to do is do the reverse of the PEMDAS steps. So we're actually going to start at the addition subtraction stage. So if I have this minus and I want to get rid of it, I'm going to actually add 19 to both sides. So I get y plus 19 is equal to x minus 4 squared. If I want to undo a square, how do I undo a square? I do the opposite, which is a square root. So I'm going to square root. Whatever I do to one side, I must do to the other. And then I'm going to get y plus 19 is equal to the square root of x minus 4 squared. That undoes each other. They undo each other. And we're left with x minus 4. And then I've got the square root of y plus 19. Again, I want to now get rid of that minus 4. I do that by adding 4 to both sides. And I'm going to have y plus 19 plus 4 is equal to x. At this stage, remember, we just swap the symbols, so you don't need to manipulate or move things anymore. You're literally just replacing the symbols. So y is equal to and then it's going to be the square root of x plus 19 plus 4. And then at this stage what we're going to do is replace y with our f inverse of x, so the inverse function symbol. And I'm going to get the square root of x plus 19 plus 4. And that's it for quadratics.